Hi everyone, and welcome to this session where I will discuss the impact of COVID-19 and other challenges with models built for retail businesses. My name is Anna Baecklund and I'm the head of data science at ICA. I lead a great data science team of men and women with different backgrounds and ages, and we drive the AI initiatives across the company. That means that I normally answer to questions such as, how should we work with AI at ICA? What are the best practices in machine learning? What tools do we need? In this presentation, I start by giving you a short background of the data we have at ICA. Thereafter, I'll talk about how Corona has affected the data, which in turn affects the analysis we can do. I give a brief description of a common model in retail, a recommendation engine. Now, I know that most presentations tend to be quite high level, whereas a lot of listeners like to listen to some more details about the models. So I thought I would give at least some kind of mathematical definition to a common recommender system. After that, I'll talk about some further challenges that we have when implementing AI. I hope there will be something of interest for all of you listening today. For those of you not working with analytics, the goal is to teach you something new about this very exciting field. For those of you who are working with analytics, I hope that you will learn something from our challenges that might help you in similar situations at your companies, or at least make you feel better in the knowledge that you're not alone. And I also want to say thank you to my brilliant colleague Karin Madsen, who also contributed to this material. Let's start with the data that we have at ICA. I usually visit an ICA store a few times a week. Other visitors might see pasta and carrots and frozen peas visiting the store, but I see data everywhere. The goods generate data when delivered to the store. How often, how much, and from where. There is information about what kind of assortment the store should have, how much space different products need, and in what order things should be placed in the store. There are prices everywhere, and a single item can have different prices in every ICA store, since the stores set their own prices. We also need to consider what prices the competitors have. And of course, what did I as a customer buy? On the receipt, we can see what products are bought together, how much was the total amount spent, and did I use a self-checkout, the cash desk, or a self-scanner? And that covers the physical store. We also have the online touchpoints where the customers plan what to shop. They search for recipes and, of course, order food online, and they get it delivered or pick it up at the store. This grocery shopping that we are all involved in, both physical and online, is just one dimension of ICA's business. The other major half is the wholesale part. The name ICA is from Inköpscentralernas aktiebolag, which is the purchasing central. So making sure our stores can buy wholesales at the best price is ICA's core business. On top of that, ICA Grocery Retail is just one part of the ICA group that has 5 segments. Apart from the Grocery Retail ICA Sweden, there is also Rimi Baltic, the pharmacy Apotek Hjärtat, the retail estate ICA Fastigheter, and the bank ICA banken. And what does that tell us? Even more data. But why do we need all this data? ICA's vision is to make every day a little easier, so we always carry that with us. When trying to understand and explain complex data flows and advanced analytical models, we try to take something complicated and use it to make every day a little easier. But just like everyone else's data, ours has been hugely affected by the corona crisis. So let's look at some charts from the previous years and do a little quiz. Are you ready? What product had a huge peak in sales in March 2020 compared to 2019? Is it chocolate? Is it toilet paper? Or is it soap? I let all of you think for a few moments before telling you the answer, but the clue is that it's something that usually doesn't peak in March every year. And the answer is toilet paper. When Corona hit society last year, the stores quickly sold out. Now, as a Swede, I was of course also affected by the toilet paper demand and supply crisis last spring. This is still funny to think about, because toilet paper is one of the things created and produced in Sweden, which means that it's one of the products we'll never really have to worry about. Are you ready for the next question? What product has sold at a constant higher level from March 2020 and onwards? Is it coffee? Is it crisps? Or is it yeast? Now, this is a trend that became very popular when people started working from home and had more time to spend on food. And the answer is yeast, because the trend I'm talking about is baking bread. What product has sold much less during 2020 compared to 2019? Is it salad? Is it meatballs? Or is it chocolate? Note that the dark purple line is the product sold in 2020, whereas the light grey line is the product sold in 2019. And this product was not a big hit in the households last year. And the answer is salad. And these are just some of the products whose selling patterns differ a lot due to Corona. As all of you are aware of, Corona is a massive public health problem that has affected all of us in many ways. The chaos and uncertainty surrounding the coronavirus pandemic have also claimed another victim, namely the machine learning systems that are programmed to make sense of our behavior. When Corona hit, we started buying things in a way we have never done before. The shift was quite sudden, and ripple effects have been seen across the retail supply chains. This has created problems for the models that run behind the scenes in inventory management, marketing, fraud detection, and many other fields. Machine learning models trained on normal human behavior are now finding that normal has changed. And while the models are built to take in new data, they perform badly when the input data differs too much from the data they were trained on. Furthermore, they are typically not so robust that they can adapt fast enough to this sudden shift in behavior. And since ICA's data has been affected, just as you saw in these graphs, this does create some new problems for us. So let's discuss more in detail what kind of machine learning problems we might encounter. A very common model in retail is the recommendation engine or recommender system. Most of you might already know how they work, but to give a short recap, recommender systems are algorithms that suggest relevant items to users, such as products to buy or movies to watch. One of the common ways to build recommendation systems is to use collaborative filtering methods. So there are other methods as well, but let's focus on these for the moment. And collaborative filtering methods are based on past interactions that are recorded between users and items in order to produce new recommendations. And we are then interested in calculating the similarity between two users or two items. And once again, there are a lot of different ways we calculate this. And two of the common ways, so two of the basic ways might be with the Pearson correlation and vector cosine based similarity measures. The Pearson correlation is the covariance of two variables divided by the product of their standard deviations. And this means that it is a normalized measurement of the covariance, so that the result always has a value between -1 and 1. The cosine similarity is a metric used to find the similarity between items or products irrespective of their size. We calculate the cosine of an angle by measuring between any two vectors in a multidimensional space, which is quite tricky to illustrate with your hands, but yeah, you get the point. So cosine is then an angle calculated between -1 and 1, where -1 shows dissimilar items and 1 shows items which are a correct match. And you can see the formula for the cosine similarity measures on the screen. And it's given by the dot product between the two vectors I mentioned earlier, divided by the product of the vector's magnitude. If we want to build a user-based top-end recommendation engine, we often use a similarity-based vector model to identify the k most similar users to an active user. After the k most similar users are found, their corresponding user item matrices are aggregated to identify the set of items to be recommended. There are several advantages with this approach, of course, as usually, such as being able to explain the results, which is an important aspect of recommendation systems. It's quite easy to create such a system and to use the model, and so on and so forth. And just as well, there are, of course, several disadvantages with these kinds of models, such as what happens when the data is sparse or when we want to add new items. And also by having a sudden change in the underlying data based on a new consumer behavior due to Corona will also make the recommendations less accurate. You might still get offers for toilet paper, even though you probably don't use that much of it. But there are more challenges with AI in retail, not connected to only one model. So let's move on to the next part, where we will discuss challenges with implementing AI in retail. Artificial intelligence, the technology that everyone is curious about. And one reason, of course, lies in its tendency to disrupt every aspect of life. And AI does indeed seem to radiate enthusiasm and skepticism collectively. Now then, there are many different ways that AI will disrupt or impact retailers. One thing that a lot of companies depend on is, unfortunately, legacy infrastructure to provide the IT operations. And redesigning everything is quite big of a challenge. One part of the challenge is then to choose what kind of new technical tools we want to work in. Should we choose an on-premises or cloud platform? On-premise is the traditional approach in which all the required software and infrastructure for a given application reside in-house. On a larger scale, this could mean that the company hosts its own data center on-site, which in some cases might be preferable if you have sensitive data. Cloud computing is an umbrella term that refers to computing services via the internet. The cloud service provider takes care of maintaining its network architecture, giving you as the customer the freedom to focus on your application. The key characteristic of cloud computing is that you pay for what you use. So please make sure to understand the platform where you spin up virtual machines. It tends to be quite expensive otherwise. Expectations versus reality is the next part. There's a lot of hype about the possibilities that AI poses for companies. When business owners hear about the promises of AI, their expectations usually go beyond reality. And then the confusion sets in on what AI solutions their business actually needs and how prepared they are to implement AI in their activities. And this leads us to the next part, which is business use cases. There are many different models you can build. However, companies often find it hard to select the most relevant problems to get started with and to see returns on. So actually prioritizing the right area of AI applications in the business is one of the most common challenges whilst trying to adopt AI. But normally, business operations together with analytics departments try to think of questions such as how to enhance the customer experience. And one answer would of course be by making sure that there is enough toilet paper and yeast in the stores. Or how to learn customer behavior better, how to increase efficiency in operations, or how to deliver better value to customers today compared to what you have received earlier. Or how do we innovate on products and services so we can increase the acceptance, the visibility, the sales, and so on. And then we have transparency. The key question here is, how does AI actually work? You send in data in a black box, which then arrives at conclusions and make predictions with the data provided through the help of some kind of mysterious algorithm, maybe the cosine similarity measurement that we all know well by now. Now, this is the wrong way to go about it, because this way leads to distrust and doubt about the models, since the validity of the recommendation or the prediction will be questioned. Therefore, the rationale behind the model calculation needs to be transparent, because we want to build up trust together with the business operations. Another problem with AI models is that they depend on the data they are trained on. which might lead to bias. Historical data is not devoid of bias, as it just shows what consumers did in the past. And this means that depending only on historical data and derived patterns might not be enough. Socio-economic context and expressed customer preferences, among other things, need to be considered, just as well as the impact the current pandemic has on our lives. And then we have workforce skills. The non-technical workforce might sometimes find AI integration a little bit intimidating, since its usage supposedly requires advanced training. So normalcy of AI in the workplace might actually be a tricky goal to achieve. There might be questions such as how to use this technology, or even which of my responsibilities are the different AI models going to take over. And of course, then we also have a challenge of making sure that the workforce actually has the correct skill set. And then back to the never-ending subject of data. Apart from Corona, there's a lot of other things that can go wrong with the required data for AI, with factors such as the volume of data, the collection of data, the labeling of data, the accuracy of data, and so on and so forth. But we also have the problem of actually getting to the data and finding people in the company that understands the data. Learning enough that you become one of these persons, understanding how to model the data. And I'm going to end with the most important thing to meet all these challenges: having the right team. Having the right team to make data accessible and actionable for the business operations. Having the right team to understand the data and to model it, and to teach the business operations about analytics. Having a team who can connect what is going on out in the world to what is going on here in the algorithms. This is something we are trying to build at ICA, and this is what we will end this session with. Thank you for listening today, and hope to see you soon.